Welcome to our fractions flip video. Please make sure that you have your recording sheet in front of you so that you can record these definitions on the lines on your recording sheet. Let's go over the definitions. And remember, if you have any questions, please feel free to ask one of your teachers, because the goal of this video is not to master this information, it's to introduce you to this information so that next week when we start teaching it, you're aware of what we're going to be learning next week. Okay. Where it says denominator, you're going to write this definition for denominator. This is the number on the bottom of the fraction. This number represents how many total pieces there are. So if I'm going to write a fraction of 4/5, this is my denominator. So you come up with your own example. And then for my non-example, I could say 2/3, and then I can have an arrow pointing or circle this one because 2/3 is going to be a numerator, not a denominator. Numerator, this is the number on the top of the fraction. This number represents how many pieces you are comparing. So again, if I have a fraction of 2/5, I could point to this as my example because that would be my numerator. And 1/5, I could say my non-example is the 5 because that's the denominator. So please make sure to write down these definitions word for word on your recording sheet on the lines where it says denominator and numerator. Pause this video and I'm going to go on, but you can pause it and record your answers. So here's an example of a fraction. There are 1, 2, 3, 4, 5 total pieces, which is the denominator. The numerator is how many pieces are shaded in and shaded red, and that would be 2. So that's the numerator and denominator. So what is this fraction? Well, there are 1, 2, 3, 4 total pieces. That's going to be my denominator. The ones that are shaded in red is 3. So this fraction is 3/4. Let's identify this fraction. There are 1, 2, 3, 4, 5, 6, 7, 8 total pieces. That's going to be my denominator, how many total pieces there are. 1, 2, 3, 4, 5, 6 are shaded in green. So 6/8 is going to be how much is shaded. 6 out of 8 are shaded. So let's talk about equivalent fractions. Equivalent sounds like equal. So are these two fractions equal? Well, if I look, I can break this into 3 chunks by putting 2 pieces for every 1 chunk. So these are equivalent because 2/6 is equivalent to 1/3. They are the same, okay? So 2/6 is equivalent to 1/3. Yes, they are because the same amount is shaded for both rectangles. Let's look at this fraction. Clearly there's 1 shaded over here out of 8, and 1, 2, 3 out of 7 are shaded. So clearly this fraction is the greater fraction. 3/7 is greater than 1/8. No, they are not equivalent because the same amount is not shaded for both of these rectangles. Okay, now you're going to go to the improper and mixed fraction words on your recording sheet, and you're going to fill in this definition where it says improper fraction. Improper fraction, the numerator is larger than the denominator. So if I had 15/3, that's my example because this is an improper fraction. If I said 1/3, this is not improper. This fraction is improper because it has a numerator that is larger than the denominator. So that makes it improper. So this could be an example and a non-example, but I want you to come up with your own example and non-example and make sure to write down these words on the lines. Mixed fraction. These fractions include a whole number and a fraction. That's why they're all mixed up, because I could say this. 2 and 1/3. Well, that's a mixed fraction because it's mixed up because it has a whole number and a fraction. If I wanted to show a non-example, I could say 2/8. That is a non-example. So where it says mixed fraction, write down this definition. Where it says improper fraction, write down this definition. Pause, and I'm going to move on. So let's look at this. Whenever you have an improper or a mixed fraction, the denominator is always going to be the same. So as you can see here, both denominators, this line is a little bit blurred up here, but both denominators are a 4. The reason why is because we are concentrating on one circle at a time. There are 4 pieces here, 4 pieces here, and 4 pieces here. That's why the denominator is 4. Okay? Now, if I wanted to count how many yellow pieces there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 yellow pieces. So 10/4 is going to be my improper fraction. Remember, this is improper because the numerator is larger than the denominator. My mixed fraction tells me that I have 2 circles that are completely filled in. So there are 2 completely filled in circles, and then 2 out of 4 pieces are shaded in. Now, you're never going to have a denominator of 4, 8, 12. That's never going to be your denominator, okay? Because, excuse me, because each circle is not split into 12 pieces. Each circle is split into 4 pieces. Yes, there are 12 total pieces, but I'm not worried about that. I want to know what is each circle split into. Let's go on. Okay, let's look at this one. My denominator is not going to be both circles combined. My denominator is going to be how many pieces are each circle split into? 1, 2, 3, 4, 5, 6. My denominator is going to be 6 for my improper and mixed fraction. So there are 6 pieces that each circle is cut into. Now, how many total pieces are there? Well, there's 6, 7, 8, 9, 10. So there's 10/6 that are shaded in. Now, if I want to show that as a mixed fraction, I'm going to put my whole number here because there's 1 whole circle filled in, and then 4 out of 6 filled in on this circle. So 1 and 4/6 is my mixed fraction. It's all mixed up because it has a whole number and a fraction. Let's look at this one. So I want to know my denominator is how many each circle is split, cut into, not combined, each circle by itself. 1, 2, 3, 4, 5, 6, 7. So this denominator is going to be 7. And then how many total orange pieces are there? Well, there's 7, 8, 9, 10. So that's going to be 10/7 is my improper fraction because my numerator is larger than my denominator. I have 1 whole circle and 3 out of 7 shaded in this circle. So that's my mixed fraction because it has a whole number. Okay, let's look at this one. What is this split into? 1, 2, 3, 4, 5. Each one of these is split into 5 pieces. So that's going to be my denominator. Now, how many total pieces are there is my numerator that are shaded red. 5, 10, 15, 16, 17, 18. 18/5. Now, for my mixed fraction, I'm going to mix it up with the whole number. So I'm going to say that there are 1, 2, 3 completely shaded in red and 3/5. So 3 wholes and 3/5. There are 3 whole rectangles filled in and 3 out of 5 filled in on that one. Let's look at this one. 1, 2, 3, 4, 5. That's my denominator because I care how many each circle is split into. So my denominator is going to be 5. And then I'm going to count and see how many are shaded in. There's 5 here and 4 here, so that's 9, 10, 11. So 11/5. Now, this is where it gets tricky. If I move this piece over here and I shade this piece in red, and then I pretend like this piece is gone, and this piece is gone, so there's 1 here. So now I have 2 whole circles, and only 1/5 left over because I moved this over here, and I pretended like this one was white. So I have 11/5 and 2 holes and 1/5 shaded in. Let's look at this last example. I have 1, 2, 3, 4. Each one of these rectangles is split into 4 pieces. So my denominator is going to be 4. Now how many total pieces are shaded in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 4 are shaded in. Now I'm going to look and I'm going to see I can move this piece over here, pretend like this is shaded in yellow, and this is gone. So now I have 2 whole squares and 2/4. Because I moved this over here, I made this a whole square. This piece I pretended like it was gone, so that gave me these 2 squares that are whole and 2/4 that are shaded in. Please feel free to watch this video as many times as you need to and ask any questions if you have any. Okay, I hope you enjoyed this video.